Hello, this section module 2 investigation 2, representing quantities and change in quantities. This lesson will improve your ability to represent how two quantities change together using formulas and graphs. In addition to conceptualizing the quantities in a problem context and defining a variable to represent the quantity's value, it is important to understand what operation to use to combine specific quantities described in an applied problem. We begin the lesson with exploring a key question. So what do the results of performing the operation addition, subtraction, multiplication, and division represent? So number one, so in this investigation two, I'm going to do number one, and then I'll do number three, and then I'll do number eight. So in number one, if the variable x represents the total number of the COVID-19 deaths in the United States since March 1st, 2020, what do the following expression represent? So A says x minus 100,000. So x minus 100,000 means 100, both should be the number of the death. Okay, so x is a meaning of the total number of the death of COVID-19 in United States since March 1st, 2020. And then you are subtracting 100,000 death from there. Okay, so about 100,000 is still death, but we don't know what it is. But that will be the 100,000 death too. So when you read this, it is a meaning of, it's going to be 100,000 less death, or fewer than, you can use a fewer instead of less, than the total number of COVID-19 death in the U.S. since March 1st, 2020. So when can we use this one? When we actually compare the death from another country. So if you think about another country, I don't know what countries I can think about, but there'll be the country that 100,000 less death than the United States. All right, 1.2x, which means it's going to be the 1.2 times as large as the total number of the death in the United States. So when you actually read it, it's gonna be the number of the death, which is a 1.2x total number of the death, that is 1.2 times as large as the total number of COVID-19 death in U.S. since March 1st, 2020. Okay. All right, what about C? C is about division. So total number of the death in United States from COVID-19 since March 1st, 2020 has been divided by 1,000. So the meaning of this one is the total number. Well, let me use a red, okay? I think that make it more clear, the distinguished, right? So the total number of COVID-19 death in U.S., of course, since March 1st, 2020, measured in units of 1,000. So if you're gonna make the 1,000 as a one group, how many groups do you think we're gonna get? Or you can also say that as how many times as large as the total number of the COVID-19 death in the United States on March 1st, 2020 is then 1,000. Okay, so that's the expression. So I represent the meaning of the expression. Okay, so now number 3. the formula C equal to 2 pi r, which is going to be define the circle circumferences, which is C is related to the circle's radius r. So in order to find the circumference of circle, you need, as long as you know what's the radius of circle, you can find it, because you just need to 2 times pi times r. So A, we're going to complete the statement, okay? So A, the circumference of any circle is how many times as large of the circle depth. So which means when you compare to get to the circumference, so let me actually use the map of the blues, okay? So circumference is always equal to 2 pi r. So when you multiply 2 pi to the r, you're always gonna get the c, right? So that means circumference is always bigger number than the radius, because you need to multiply 2 pi to the r. So A means the circumference of any circle is 2 pi times as large as the circle's radius. But what about radius? Radius is any circle is how many times as the circle's circumference. So because of this, since C is a 2 pi r, and then I need to solve for r, because we are talking about r this time, right? So if you solve for r, you're going to divide by 2 pi both sides. So the radius is always the circumference and then divide by 2 pi. So which means this is same as 1 over 2 pi has been multiplied by c. So the radius of any circle is blank times as large as the circle's circumference, which means it's going to be 1 over 2 pi. C, describe at least 2 different ways to interpret what c over 2 pi. So c over 2 pi is going to be the length of the radius of the circle, okay? So it's going to be the c over 2 pi represent the length of the radius, which is r of the circle, and also the circumference C is circumference C of the circle, which is any circle, is C over 2 pi times as large as 2 pi. Okay. So let's look at the D. Describe the listed 2 different ways to interpret the C over R. So they are actually the answers are already the 2 pi, which means the length of circle's circumference measured in units of its radius. Okay. Or the circumference of C of any circle is C over R times as large as the length of the radius of circle. So you can just read as whatever that is, okay? And then let's look it up to see. Given the radius of the circle, we drawn below, construct which is this is the length of the radius of the circle. Construct a line segment with the length of the approximately equal to the circle's circumference. So how are the length of the disc segment related? So we need to know between the relation between the radius and the circumference. So if the radius about this, right, about this, and then what do you need to multiply to get the circumference? So how many times? So 2 pi times more, isn't it? 2 pi times more. 2 pi times as large as the circle's radius. Because I already talked about here. Right? So C is 2 pi r. So we need to figure out how much is the 2 pi is. So 2 pi is almost 6.28. So circumference is almost 2.28 times as large as the radius. So I'm gonna make the 6 pieces and then the little bit more piece after that, okay? So let's say this is one piece, same as the radius 1. And then I wanna get a similar to number 2. And then 3, should be the same thing, 4, 5, 6, and then I have to go only 4 to the little bit for the point to it. Maybe about here. Okay, so this is the length of r, which is a radius, and then this is the length of the circumference, because circumference is always approximately 6.28 times as large as the radius of the circle. Okay. All right, so this is the questions for the number 3. And then let me go to the number 8. So in number 8, which is this question actually might come back later too. All right, so Sam boards a ferry wheel from the bottom and rise around several times before getting off. This graph represents the Sam's height above the ground in feet with respect to the amount of the time in seconds since the Ferris wheel began moving for one complete rotation of the wheel. So this is only the one rotation, okay? So she was at the 0 second, she was here because Ferris wheel must be above the ground and they can actually rotate in the air, right? So the place that the person is above the ground, and then the time goes by, and about the 10 second the Ferris wheel actually went on the top place, which is the Sam's height from the ground is the highest place, and then another 20 minutes and then it come back down to the that's the lowest place of the from the ground, okay, in the Ferris wheel. Okay, so A, the 0.2 and 4.9 is plotted at, which is right here, on the graph. Explain what this point conveys in the context of the Ferris wheel situation. So the x-axis represents the amount of the time in seconds since the Ferris wheel began to move, and then the y-axis is actually representing as a Sam's height above the ground as a feet. Okay, so which means x-axis is the meaning of, so the 2 is the meaning of x and 4.9 is the meaning of y. So this means that then 2 seconds after the Ferris will begin moving, Sam's height above the ground was 4.9 feet. Okay, yeah, so 2 means the elapsed time, which is 2 seconds, and the 4.9 is the location of the Sam's above the ground. Okay, how about B? Complete the sentence as the number of the seconds since the Ferris wheel began moving increased from the 0 to 20 seconds. Sam's height above the ground is, okay, So she moves from the 0 to, she moves to the 0 to right here. So she moves to the 0 second to the 20 seconds. So they're talking about here, right? It's all the way here. Okay, so they're talking about from all the way to here. Okay, and then what happened? So well, her actually uh, or her height from the ground is actually getting larger all the way up to the 10, and then getting smaller from the 10 seconds. Okay, so I can say that as increases until he reaches the top of the Ferris wheel, and then decreases until he reaches the bottom of the Ferris wheel. And then letter C. As the number of the seconds since the Ferris wheel began to moving increases from the 2 to 8 seconds, how does Sam's height in feet above the ground change? Okay, so we're gonna actually make the vector to use. So which means from the 2 to 8 seconds, 8 seconds right here. So the time changed from 2 to 8 seconds, and then her height from the ground is his height. Sorry, Sam's height. Height is changed this much. Okay, so as the number of the seconds since the Ferris wheel begin to moving increases from the 2 to 8 seconds, and then the change is represented as a vertical vector, which is I put that right here. So this is what I'm talking about. Okay, this is a vertical vector. Okay, so vertical vector which is pointing up, that has been drawn on the graph. Okay, I already did it. That magnitude for the vector magnitude is the length of the vector. Okay, approximately, I want to say it's about here, right? So each interval is about 3. So I want to say this is a 27. Okay, so it's going to be 27 subtract 4.9, which makes a 22.1. So 22.1 feet has been changed. Now the letter D. As the number of the seconds since the Ferris wheel began to move increases from the 10 to 16 seconds, so it's from the 10, so from right here, okay, and then to the 16 seconds. So where's the 16 second? Right here, isn't it? Okay, so the times go this way. So let me use a red. Okay, so times change this much. Okay, from here. Okay. Alright, so that's what they're talking about. What was the change in Sam's height in feet above the ground? Represent this change on the graph and with the mathematical expressions. So this time, well, the feet is the height is actually the drops. It's because the the vector go down about here, right? About this time, okay? So as the number of the seconds since the Ferris wheel began moving increases from the 10 to 16 seconds because times increases always, right? And then the change is negative, right? Because it was the highest point at the 10 second, and then Sam's height of above the ground decreases. But by how much? It's from the, so about the height at the 16 second was about 12, right? So I'm gonna say 12 subtract, and from the, this is actually the 30, right? So 30 feet, which is, I gotta get negative 18 feet. So you change the negative feet. That means a decreasing. So about the 18 feet. 18 feet. But, okay, but you can make the extra value because it's going to be the distance anyway. So we will be consistent in representing a decrease in value of the negative change, and then increase in the value as a positive change throughout the course. Okay, so I need you to remember that. And then the letter E was not that clearly shown here, but the letter E says, let T represent the value of the horizontal axis, which is the seconds. Write a complete sentence that describes what value of the T represent in the context of this situation. So let T represent, which is the number, okay, which is, we try to explain what is the meaning of T, of the second, since the Ferris wheel begin moving. And then F, define the variable h, which is the vertical axis, so that it is represent the varying value of the dependent quantity in this situation. When defining a variable, remember that you must always say that where the measurement begin. For example, since 10 a.m., the direction of the measurement north of the starting line, and this state the units like a second, feet, square, inches, as etc. was like the quantities. Okay, so we're gonna say that let h represent, it's gonna be the Sam's height above the ground. Since the Ferris wheel began moving. Okay, all right, so this is for the module 2 and investigation 2. All right, thank you.